Alright, so we're going to go through the first example. Okay, with our first example, again, one of the big steps to this that we don't talk about is identifying what rule to apply. Yes, we know we need to find a derivative, but what rule do we apply? We can see from the start it's a chain rule. How do we know it's a chain rule? Jared, how do you reckon we know that one's a chain rule?
Because it is all in brackets and it's only got a cube listing.
Yeah, so we've got a function to a power. So a function inside a function, which means that we apply a chain rule. We let u equal the thing inside the brackets there, the power. We derive the u dx. We represent y in terms of u, and then we derive the y to u. Are we good with those? Good with that step? We sub that back into our formula, dy to u equals du dx. That works because our du's cancel. And we're left with dy dx equals dy dx, which makes perfect sense. We then sub in our variables. Please be aware that when we sub in our u, we cannot do it like this. Why can't we do it like that? I saw a lot of people do this. Why can we not do this like this? This whole thing is du dx, correct? We need to represent that with brackets because it's dy to u times du dx. What you've got here is dy to u times negative 6x, which isn't the whole lot of du dx. Does that make sense? So just make sure that we're putting our brackets in. From there, we can expand the 3 into either one. I've chosen to expand the 3 into this one. Why have I chosen to do that? Can I do it to the u or not? Why can't I do it to the u? Bomdas says, what must I do first, multiplication or index? Index. So if I wanted to expand it into the u squared, I'd have to get rid of that squared first, and then expand the 3 in. Does that make sense? But I can expand the 3 into whichever one I want. That's as simple as I can get it, so I leave it there. What could I have done if I wanted to simplify it? Expand it. When would I, if this was a number, I probably would do that. If this was just a numerical value, I probably would do that, but that's not going to be any kind of. Cool? For question 2, what rule are we asked to use? Quotient rule. Just the quotient rule? Or another rule with it? Just the quotient. How do we know to use the quotient? Because function divided by function. With this one, it's really important that we set our variables the right way. Because we're new to the game, I changed the function from fx to gx, so that we can keep our variables the same as what we've seen. I've then defined fx to be the top and hx to be the bottom. It has to be that way. Cool? I could have also used u and v. It doesn't matter which way I chose. I then derive each of these terms, and from there it's about recalling my rule and substituting in. Make sure that hx is our first term. Sweet? Hx by itself is our first term. I'm going to guess that almost every person in the room got to this point here, correct? The challenge from there isn't about, it's no longer about derivatives, is it? It's no longer about derivatives. What's it about? Simplifying. So from there, because we can see that we've got no powers on the top, if we expand those brackets, we're going to be able to cancel some like terms, and we should just be left with a linear equation on top and a quadratic on the bottom. When we do that though, we're even more fortunate because we get no x, because when we expand that, we get 24 minus 24x, which leaves us with 0x, negative 8 minus 18, which leaves us with 26. We're almost all the way here. What's the last step? I've simply just taken a common factor out. What's the common factor that I've taken out? 2. I can't do anything else, that's my final answer. I should have represented it as g dash x like that to get my full communication. Sweet? Yeah.
Do we have to always put in g dash x for every single line?
No, just, doesn't hurt. Doesn't hurt.
Got it.
But if you miss it every now and then, like what I've got there is not too bad. Sweet. What are some things that we can look for when we're cancelling this? What are we trying to find? What's the trick to cancelling? What did I look for here? Once I got to this point here, I look for common factors. That can pop up all the way along. Particularly as we deal with exponential derivatives, which we're not doing yet, but when you derive exponentials, there's a special trick that means you get a lot of cancelling opportunities on the top and the bottom. Always look for opportunities to cancel out and simplify our functions from there. Particularly relevant for all three of these rules. But it happens a lot in the quotient rule and a bit in the chain rule. Sweet. You guys can progress through with that. That's basic task. Yes, Tom.